of whatever it is that we're looking for, or possibly the smallest, or the least. So for example, if we want to create something that has a large area, we're optimizing area. But on the other hand, we may also want to optimize revenue. So we may want to make the most money, but on the other hand, we may want to minimize a cost. Okay? So optimization problems involve looking at trying to find the largest of something or the smallest of something. Okay, so the example I'd like to look at starts like this. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions of the box that minimizes the amount of material used. Okay, so after I write down the problem and then I read it a few times, I look at it and I realize what's happening here is that we've got some sort of product that we're trying to create. And whatever this product is, this box, it must hold a volume of exactly 32,000 cubic centimeters. Okay, so whatever product we're going to put in this box is going to fill up 32,000 cubic centimeters. Now, we want to do this with the least amount of material possible because, well, I mean, the less material you use, the cheaper it will be to create this product. So our job is to minimize the amount of material used. Okay.
I've got a quick question. Would you be able to put that into meters and it'd be okay?
Sure. We could translate this into meters as well, and we could work with maybe some smaller numbers if we wanted to.
Okay.
Yeah. Okay. Well.
So the base has to be square, but the sides don't.
That's correct. So as long as our base is square, our sides can be very tall, or they could be very squat, very short. So it doesn't necessarily have to be a cube. It could be a very tall box with a very small base, or a very wide box with a short height. Okay. So these are all sort of possibilities that could happen. The only requirement is the base must be square. Okay. So when I go back to read the problem and I see the word minimize, or in some of the other optimization problems, find the largest or whatever it is, here I'm trying to find the smallest amount of material used. Now the way I want to translate amount of material used, I want to translate that into area of the box. So in other words, I want to look at minimizing the surface area of the box. And so as soon as I identify what it is that I'm trying to maximize or minimize, that is what I want to find a formula for. So we want to find a formula for area. All right, so in terms of this box, a couple of comments were made. The requirement that the base must be square. And then my box must have an open top, meaning I'm not going to be putting a lid on this box. Now, the height of my box could be very tall. It could be very short. I have no idea, but I cannot in any way assume that this box will be a cube. In other words, that the height will be the same as the length of the base. Okay, so here's a picture of the box that I'm looking at. And it has an open top, so I'm going to color in the top to indicate that I'm not including that part of the box. Okay. So some other information in terms of the dimensions of this box. Since the base is square, we can give the same label on both the length and the width. So might as well call them both W for width along the bottom. And then we need another label maybe to measure the height of the box. Anybody have a vote for what letter they'd like to use for the height of our box?
L.
L? Okay, we can go for L. Okay. So we've got two W's because our base is square, so W and W, and then the height of our box, or the length of our box, we'll call L. Okay, so our goal is to minimize the surface area of the box. So in terms of this box, we want to find a formula for the area, or the surface area of this box. All right, so take a minute and think about how you might write down a formula for the surface area of this box. And then write down what your thoughts are. All right, so now turn to your neighbor and see what their thoughts are.
Plus W.
I thought 1, 2, 3, 4. So there's surface area, right?
Or surface area. Or surface area, right?
Or the height.
L times W times 4. These are all.
Oh, length times width, but isn't that?
Well, this is, well, so